Good morning, fellow mathematicians. A lot of people requested that I should make some videos in English, so I will try my best. I haven't done any English videos in like, I don't know, 5 years. So I hope my English is still kind of good and I can speak fluently, and I hope that those videos won't be too sloppy, so I will try my best. And today we are going to start with the integral from 0 to infinity of 1 over x to the 4th power plus 1. And we want to solve this bad boy. But we don't want to solve it using contour integration or complex analysis. We just want to solve it algebraically. So let's try our luck. So at first we don't exactly want to solve this integral. We want to convert it a bit. So we want to introduce a parameter. And we want to call this one the new integral. So 1 divided by x to the 4th power plus 2x squared times the cosine of 2a plus 1. Okay, so how is this integral the same as that one? So we still have the same upper and lower bound. Okay. As you might notice, if you plug in pi over 4, then the cosine becomes 2 times pi over 4, and that's pi over 2. And the cosine of pi over 2 is just 0. So if you plug in pi over 4 as a, then you will get the original integral. So this case holds for a equals pi over 4. Okay, and we want to solve this one. So let's get started. At first we want to introduce U-substitution. And you might not come up with... So at first we want to introduce a U-substitution, and you might not easily come up with it. So it's kind of counterintuitive, and yeah, let's just introduce it and then we will see what we can do with it. Okay, let's start off by saying u equals 1 over x. So that's equivalent to x equals 1 over u. Okay, and we still have to differentiate this u. So du equals minus 1 over x squared times dx, or if you differentiate the right hand side of the equivalence, so that's equivalent to dx equals minus 1 over u squared du. Okay, and we can plug all of this into our integral. Okay, so we will call this integral I. So that's nothing else as an integral I. And it's in terms of x. So I now equals, okay, if we plug in 0 into this equation, it means u becomes 1 over 0, and that goes to infinity. So our lower bound equals infinity. And if we plug in infinity into this x, then it's 1 over infinity, and that goes to 0. So our upper bound is 0. Okay, at first let's plug in our dx. Our dx equals minus 1 over u squared du. So yeah, let's plug this in. That's minus 1 over u squared du. Okay, and let's change all of our x's to some u. Okay, so x equals 1 over u. So x to the 4th power equals 1 over u to the 4th power, and plus 2, 1 over u squared times cosine of 2a, plus, and 1 just equals 1. Okay, so what can we do next? You have to notice that there's a minus in here. So we can bring it to the outside, and then we can change our bounds. Okay, so our integral is now just the integral from 0 to infinity of 1 over u squared times du divided by our denominator. So what can we do next? As you might notice, you can multiply this whole thing by 1. And by 1 I mean you can say it's the same as if you would write times u to the 4th divided by u to the 4th power. Okay, and we can distribute that on all the terms. So this now equals our integral from 0 to infinity of u to the second power times du divided by 1 plus 2 u to the second power times cosine of 2a plus u to the fourth power. And now, here's the important thing that you might notice. So, this integral equals I, and substitution doesn't change a thing, so this whole thing is still our I. So it doesn't matter if there's a u right here, or an x, or an a, or I don't know, anything else. So we can just say that's the same as the integral from 0 to infinity of x to the second power times dx divided by the denominator in terms of x. So yeah, what can we do next? We could, for example, add those two integrals together, and that would give us 2i. So let's just write. So 2i equals, okay, we have the integral from 0 to infinity of dx divided by x to the fourth power plus 2x squared times cosine of 2a plus 1 plus the integral from 0 to infinity of x squared times dx divided by x to the fourth power plus 2x squared cosine of 2a plus 1. And the good thing is our denominators are the same and our bounds are the same, so we can just add them together because, yeah, linearity of the integral. So let's try it. That's the integral from 0 to infinity of 1 plus x squared divided by x to the fourth power plus 2x squared times cosine of 2a plus 1 in terms of x. Okay, and we are nearly back at our original integral. We can just divide by 2 and then we get I again. So I isn't anything else than 1/2 divided by 2 times the integral from 0 to infinity of 1 plus x squared divided by x to the fourth power plus 2x squared times cosine of 2a plus 1 times dx. Okay, one last thing you might notice, this integrand is of course an even integrand. So if you plug in minus x, you will get this integral in terms of x again. So I of minus x equals I of x. So there's one thing we can do if you have an even integrand. You can just say that the integral from 0 to infinity isn't anything else than 1/2 the integral from minus infinity to infinity of the integrand. So this equals to 1/2 times 1/2 the integral from minus infinity to infinity of 1 plus x squared divided by x to the fourth power plus 2x squared times the cosine of 2a plus 1 times dx. And that's where we're at right now. Let's move on. So I multiplied the 1/2 and the 1/2 and I got 1/4. Okay. And now we want to continue with the integral. Okay, what can we do? So our denominator doesn't look very good. It looks kind of nasty right now, so we can't do anything with it at the moment. So we should do something against our denominator and change it a bit. So at first we want to take a look at cosine of 2a. So cosine of 2a. So what does this equal? As you might notice, that's a double angle formula for the cosine. So that's nothing else than cosine squared of a minus sine squared of a. But as you might notice, cosine squared of a is nothing else than 1 minus sine squared of a. So we can conclude that cosine of 2a is nothing else than 1 So we can conclude that cosine of 2a is nothing else than 1 minus sine squared times 2, because we got 2 times the sine squared of a. Okay, and yeah, what can we do with it? We can just plug it in and then let's see what we got. So x to the fourth power plus 2x squared times the cosine of 2a plus 1 equals. So this equals x to the fourth power plus 2x squared times 1 minus 2 sine squared of a plus 1. So we can distribute this 2 times x squared. And then let's see what we get. So x to the 4th power plus 2x squared minus 2x squared sine 4x squared, sorry, sine squared of a plus 1. And what can we do next? So we can factor this one here, and that's not too hard because we have the difference of 2 squares. If you don't see it, I will just write it on the chalkboard and then you will see it, I guess. So we want to look at this term first. So x to the 4th power plus 2x squared plus 1. What does that equal to? Yeah, that's nothing else than x squared plus 1 squared. Okay, and minus 4 x squared sine squared of a. And like I said, it's the difference of 2 squares because we can say this term on the right side is nothing else than x squared plus 1 squared minus 2 times x times sine of a to the 2nd power. That's the same thing. And now we can factor this one into 2 factors using the formula for the difference of 2 squares. So that's nothing else than x squared plus 1 minus 2x sine of a times x squared plus 1 plus 2x times the sine of a. And that's it. We finally factored our denominator and we can plug it into our equation and let's see what we get. So this equals 1 over 4 times the integral from minus infinity to infinity of 1 plus x squared divided by, so x squared plus 1 minus 2x sine of a times x squared plus 1 plus 2x times the sine of a times dx. Okay, and that looks way harder than the integral we got before, but we can use a little trick here. So I hope you agree with me that this term equals this term plus a 0, because the 0 doesn't change anything. But what is the 0? We can write the 0 in terms of an integral. So we can say this 0 does equal, so I will write this again, 1/4 times this term plus x squared divided by x squared plus 1 minus 2x sine of a times x squared plus 1 plus 2x sine of a, okay, times dx. Okay, and now the plus 0. So the 0 is nothing else than 1/4 times the integral from minus infinity to infinity of, okay, what do we get? Maybe we can say this is nothing else than minus 2x sine of a divided by our original denominator, or this denominator, it doesn't matter, it's the same term, so I will just use this one because it doesn't use up too much space. So x to the 4th plus 2x squared cosine of 2a plus 1. Okay, why is this 0? Yeah, as you might notice, we have an odd integrand in this one. So if you plug in minus x, this would equal to minus the function of x. So if you got an odd function and it goes from the lower bound minus a to a, for example, this will completely vanish. And yeah, we just got a 0. So we can add those two together, because why not? Okay, and if we add those together, it's 1 over 4 times the integral from minus infinity to infinity of 1 plus x squared minus 2x sine of a divided by x squared plus 1 minus 2x sine of a times x squared plus 1 plus 2x sine of a times dx. And that's absolutely brilliant, because we can cancel out those two ones, because those are the same. So this cancels out and this cancels out, And what we are left with is 1 over 4 times the integral from minus infinity to infinity of dx divided by x squared plus 1 plus 2x sine of a. And that's really nice, because it's way easier now. And the good thing is we have a 1 in here. And what does 1 equal? Yeah, 1 is nothing else than cosine squared of a plus sine squared of a. So let's plug this in. That's 1/4 times the integral from minus infinity to infinity of dx divided by x squared plus 2x sine of a plus cosine squared of a plus sine squared of a. And that's good too, because we can factor this one out. So x squared plus 2x sine of a plus sine squared of a is nothing else than, okay, so that equals to 1 over 4 times the integral of dx divided by x plus sine of a squared plus cosine squared of a. And now we can move on. So what we are left with now is this little integral, and that's really easy to solve, because that's nothing else than the inverse tangent of something. So let's solve this one, and then we are as good as done. So that's 1 over 4 times 1 over cosine of a, okay, times the inverse tangent of, okay, we got x plus sine of a divided by the cosine of a from minus infinity to infinity. Okay, and that's in terms of x, so we don't have to plug anything into the a. And yeah, let's just plug this in. So if we plug in infinity into here, that means it's the inverse tangent of infinity. And if we plug minus infinity into here, it's the inverse tangent of infinity. So that's 1 over 4 times cosine of a times, okay, what are we left with? That's the inverse tangent of infinity, or the limit when n goes to infinity, I don't want to write it out, minus the inverse tangent of minus infinity. Okay, so what's the tangent of infinity? So what's the inverse tangent of infinity? Just think about when does tangent of x go to infinity? Yeah, if you go close to pi over 2, so that's nothing else than pi over 2. And the inverse tangent of minus infinity, think about when does the tangent of x go to minus infinity? Yeah, when you have minus pi over 2. So that's 1 divided by 4 times the cosine of a times pi over 2 minus pi over 2. And that's just pi. So our final result for the integral is nothing else than pi over 4 times the cosine of a. But we are not done yet. That's just the result for our integral with the cosine in the denominator. And as we said in the beginning, we want to evaluate this integral for the cosine for the a value of pi over 4. So we just have to plug in pi over 4 and then we are done. So that means our integral from 0 to infinity of dx divided by x to the 4th power plus 1 equals pi divided by 4 times the cosine of pi over 4. And the cosine of pi over 4 is nothing else than 1 divided by the square root of 2. Yeah. So we got pi divided by 4 times 1 over square root of 2, and that is just the square root of 2 times pi divided by 4, and then we are done. So that's the result you get if you evaluate this integral. And I hope you liked this video, at least a little bit. I guess I have to cut it a bit, because, yeah, sometimes my English is a bit sloppy. And I'm not very confident in it anymore, so I have to get used to it again. But still, I hope you liked it, and yeah, if you did, then subscribe and leave a comment what you thought of this video. And yeah, thank you for watching, and have a nice day. Goodbye.
Anton, such.